Hi, hi students. So I am Rekha, Assistant Professor, Department of Mathematics, Dr. S.N.S.R.CAS College of Arts and Science. So today we are going to see the topic that is queuing theory. So let's see the problems in the queuing theory. In previous video we have discussed the model that is 1. Now we are going to discuss the model 3, that is m/m/n FIFO. This topic is from resource management technique. This topic is from the unit 3 of resource management technique course. Okay, let's see the queuing theory. So directly we can go to the problems in the queuing theory. In previous video I have explained the model 3 and now we can see the problems in the queuing theory of model 3. So what is mean by model 3? Model 3 is nothing but m/m/n FIFO. Okay. So FIFO is normally, we can see it is an first in first out. N is nothing but an finite number of customers only allowed in this model. Okay, compared to the previous one, infinite number of customers can arrive the yard. But in this we have to check only finite number of input will be allowed. So let's see one problem. A railway station only train is handled at a time. The railway yard is sufficiently only for 2 trains to wait. Okay. So while other is given signal to leave the station. Train arrive at the station at an average speed of 6 per hour, whereas the railway station can handle them on 12 per hour. So assume that an Poisson arrival and exponential service distribution. And also we have to find the average waiting time of the new trains come into yard. So normally there is a 2 types of patterns is there in queuing. So queuing, everyone know it is a waiting time, and you have to analyze another pattern. One is arrival pattern and another one is a service pattern. Normally arrival pattern is represented in the form of a lambda, whereas the service pattern is represented in the form of a mu. So how many number of customers arrive, we can say lambda, and how many customers are served, we can say it is a service rate. Let's see in this problem, we can take 1 hour per day, we can say it is in 6 trains. 1 minute is nothing but how many minutes? It takes 60 minutes. We have to convert the hour into minutes. So 60 by 6 by 60 you will get 1 by 10. Similarly, service rate is 1 hour equal to 12 trains we can service. So 1 minute equal to 12 by 60, mu equal to 1 by 5. So if you want to calculate the lambda and mu, then we have to calculate the rho also. So in this we have mentioned that number of trains is nothing but an given input is nothing but an 3 trains can be allowed in the yard, we can wait. So rho equal to lambda by mu. Lambda by mu is nothing but 1 by 10 into 5 by 1. Lambda is 1 by 10, mu equal to 5 by 10. 5 by 1. Divide, you will get 1 by 2. So let's see that rho can be represented as 0.5. Next, what is the another calculation? We are going to find the steady state probability of the various number of trains in the system. So in order to calculate the steady state, that is nothing but P naught equal to 1 minus rho by 1 minus rho power n plus 1. Already rho is nothing but 0.5 we have noted now. So 1 minus 0.5 divided by 1 minus 0.5 whole to the power of 3 plus 1. So what is your n? That is 3. So 3 plus 1. Okay. 3 plus 1 will get 4. So 1 minus 0.5, 1 minus 0.5 in your calculator you have to calculate as 0.0625. So 5 by 0.9375 means we get the answer as 0.53. So this is the probability of number of trains in the system. Next thing is En, that is expected average number of times we are going to calculate the whole, on and whole we are going to calculate. So that for the formula for this is P into 1 minus rho power n into 1 plus n into rho power n plus 1 by 1 minus rho into 1 minus rho power n plus 1. So same calculation, instead all the row takes the value as 0.5. Already we have calculated, n is nothing but 3. So apply the value of n and n plus 1 in that. So if you calculate that n plus 1, you will get 0.5, 3 plus 1. And 3 plus 1 is nothing but 4. So 4, what is the 0.5 whole to the power of 4? 0.0625. That we have to calculate using the scientific calculator. Already I have mentioned. So 0.5 into 1 minus 0.5 plus 0.1875. So this you divide, will get 0.5, 1.467. So multiplying this 2 will get 0.733. So this is the expected, that is average time. What are the two things they have calculated? So one is the finding the average and another was probability. So two calculation we have completed based on the expected variance. Okay. So Pn is also they have calculated, P power n, P naught, P1, P naught. P1 is 0.5. Then P2 means already 0.5 the whole square is 0.533. 0.5 into 0.5 you will get 0.25 and you got the value as 0.13. P3 is P3 P naught 0.5 the whole cube. So 0.15. You multiply this 0.5 3 times means 0.5 into 0.5 into 0.5. Okay. So these calculation you can solve in the calculator. So after finding all the value only we can apply in this problem. Okay. Have you understand how to solve? Let us see the another problem. One barber shop contains to arrival that rate according to the Poisson fashion. The arrival rate of 5 per hour and the cutting time takes the 10 minutes. And what we have to calculate the average number of customer in the shop and the average number of customer waiting for a haircut. So same thing, arrival rate we are going to calculate as well as a previous problem. 1 hour equal to 5 means we have to convert into 5 into minutes, 5 by 60. And lambda is nothing but 1 by 12. If we cancel 5 by 16, 5 table 1 times 60, 12 times in 5 table. 10 minutes for one customer means 1 by 10. So rho equal to lambda by mu. We have to divide the 1 by 12 into 10 by 1. We will get 5 by 6. This is your what is the question? We are going to find the average number of customer in the shop. That is the formula for the average number of customer is rho by 1 minus rho. So what is the value of rho? 5 by 6. Either you can write it as 5 by 6 or you can divide the 5 by 6 as decimal you can convert. So 5 by 6 by 1 minus 5 by 6. So 1 minus 5 by 6 we have to take LCM. 6 minus 5. 6 minus 5 1. So we will get 1 by 6. 6 get cancelled. We will get 5. So this is the average number of customer in the shop. So I think so it is very easy. You can understand the queuing model problem. That is model 3 we have solved 2 problems. This model have a finite number of customer intake. Okay, so based on the question you have to answer what are the content, what are the formulas we have to apply. So I have given the problems also. So thank you students, make use of it. This is from the unit resource management technique queuing theory. Model 3 problems is from model 3 problems M/M/1 N FIFO. So we have 2 problems we have solved. Okay students, thank you.